In this video, I share with you the exam that recently happened in NUST, and I want to share the solution of this exam, that is the midterm exam that occurred in NUST. So, the first question is to find the or identify the surfaces. What kind of surfaces do you have? The first equation is ellipsoid. That is the answer. That is the answer. The question was, what is the name of this surface? And the second question was, what is the name of this surface? This is hyperbolic paraboloid. Then the C was a bit tricky part, but you can solve it very easily by completing the square. By completing square, you can find out that at the end you get this equation. Mistakenly, you can identify this as an sphere, but this is not a sphere. This is not a sphere. This is actually ellipsoid. What you will do, you will divide this whole equation by 4. Here 4, then 4, then you get 1. So this is also ellipsoid, which is centered at 1, -2, and 0. The D part, we need to identify this surface. This is hyperboloid of one sheet, and the E part is hyperboloid of two sheets. The second question was a glider is soaring upward along the helix. This is helix, equation of helix. How long is the glider's path from t0 to t is equal to 2 pi? How long means it is the distance between 0 to 2 pi. The glider is moving up like a helix, so we need to find the distance from its initial point to the final point. So what we do, we just differentiate vector valued function, find the magnitude of the derivative, which is 2 under root, then use the formula, which is the formula a to b dr by dt magnitude dt. Then you, after solving it, you can easily get the solution. Now this is the third question that appeared in the exam. So the first question was the A part, was the question 3A part. It was to define the curvature. The simple definition you start from curvature for the curvature is the unit tangent vector changes with respect to arc length. So this is the definition, very easy one. Now the B part is a bit tricky. In B part, it has been asked, find the arc length parameterization. It means that you need to find the S when T naught is equal to 0. R is given, and surprisingly, this is also helix. So this is helix. So this is helix as well. So then use the resultant curve. It means that when you convert that t into s, there should be s by some value, s. So then you have the uh, reparameterization. So how we do that? First, you need to differentiate as we did earlier, take a magnitude. Then there is a formula that says that t naught to t, and there is r dash t magnitude dt. So the difference between the length formula and the arc length formula is it starts with some fixed point, fixed time, and the upper limit is t. So s is equal to, after solving that, you get this value, and by separating t, you get s over 2 under root. Put that value over here, where? In the r, in the given vector valued function. Now this becomes very easy. Now the question has been asked to use this formula and calculate the curvature. Now the simple definition of curvature, as we discussed above, is dt unit vector by ds magnitude. So you can take You first find the t unit vector. This is dr by ds, actually t unit vector. Then differentiate and you get 1 by 2. 1 by 2 is the answer. Question number 4 has been asked, in question number 4, it has been asked to find the tangential and normal components of acceleration, and r of t is given over here. So first we differentiate to find the tangential normal components. First we differentiate, take a magnitude which gives us speed, and tangential component says that we take a derivative of speed. Speed is not a constant. You can see that it is a function of t. So a tangential component is 1. And the normal component from the theory, we know that it is curvature time velocity vector magnitude square. So it is similar to what we have. Uh, it is 1. Then the curvature, we use the curvature formula. And after using curvature formula, we use t unit vector. Since we need curvature as well, we need to put that value over here. Dt unit vector over dt is 1. The magnitude is 1. After putting that value into the curvature formula, curvature is 1 by t. Velocity vector magnitude square is t square, so we get t. So the final answer is the tangential component is 1. Tangential component is 1, and the normal component that you have to remember or memorize it some way, you get this formula. Question number 5 is also a very tricky question. It's you have to apply the chain rule. The question is, if resistors of R1, R2 and R3 ohms are connected in parallel to make an R ohm resistor, the value of R can be found from the equation. This is the equation for R. Find the value, partial derivative, when R1 is 30, R2 is 45 and R3 is 90 degree, 90 ohms, I'm sorry. So here the tricky part is that R is in the reciprocal form. So first we need to apply the chain rule. We apply the chain rule on the left hand side, and we differentiate this whole equation with respect to R2. Since when you differentiate with respect to R2, R1 is constant, this is 0, R3 is constant, this is 0, and on the right hand side we apply the power rule, which is minus 1 R2 minus 2. So here we get minus 1 over R2 square. On the left hand side, this is tricky. When you differentiate with respect to R2, 1 over R, it becomes partial R2, R minus 1. You need to apply the chain rule, minus 1, R minus 2, partial R by partial R2. So that's how you uh, yes, I think this is r square. Yes, there is an error, I guess. This should be r square. R square, okay? On the right hand side, we have r square. So r square divided by r2 square. The problem with this question is, this equation, in fact, is on the right hand side, in order to find the value of this at these points, we need a value for r. That r can be obtained when you put r1 over here, r2 over here, then r3 over here, and then take a reciprocal. So we put it that value over here, and after that approximately we get 15. So after putting that value, we get this answer, which is approximately 0.11, so on. It doesn't matter. So you can also get by using another way 1 over 9 as well. And the last question of this exam was to explain first the directional derivative. Directional derivative is very simple to answer. It is given over here, and the part B was to use this definition of directional derivative to find the directional derivative. So x naught is 1, y naught is 2, u1 is 1 by under root 2. Actually, it is given in the question. The u hat is given is equal to 1 by under root 2, uh, which is I plus 1 by under root 2 j. So so we put that value into that function, and after putting that value which is given, this is the function which is given. So x is this value, we put that over here, and then this is y, we put that value over here, and after putting that value we get this function. And fx naught y naught we have 3, and we use only the definition. In the question it has been asked to find the directional derivative by using this definition. Okay, so by using this definition, uh, if you are using, for example, del f dot u hat, it is also fine, but not exactly which is required in the question. You can get the same answer, which is the, what was the answer over here? Answer is over here, 5 over 2 under root. This is the answer. Okay, so this was the exam that appear, that is the question for the students. So I share with you the exam and its solution, midterm exam it was. Thank you for watching.